Alright, in this video I'm going to go over the fourth learning objective of this section. It's called the rationalizing technique. In the previous video we learned in fact factorization to be able to use the dividing out technique. So rationalizing technique is also relying on algebra, and let's see what it is exactly. The rationalizing technique is heavily depend on multiplying the numerator and denominator by the conjugate of the numerator or denominator. So for example, if you have a rational function radical x plus 4 divided by x, if you want to rationalize the numerator, you're going to multiply top and the bottom by the conjugate of radical x plus 4, which is exactly equal to radical x minus 4. So all you're going to do here is multiply this quantity by radical x minus 4 and divide by radical x minus 4. In turn, you will have x minus 16 at the top, and in the bottom you have x times radical x minus 4 after you simplify everything. So this way you get rid of the radical term in the numerator. Instead, you have x minus 16 coming into the new numerator. You still have the radical term popping in the denominator, but you will see that it's very helpful in this case to rationalize the numerator or pushing this term all the way to the denominator. And here's an example. So we have a rational function, radical x plus 1 minus 1, all divided by x. The limit point is 0. Okay, so let's see what happens if we substitute 0 for x. So let's see. So it becomes radical 0 plus 1 minus 1 divided by 0. So that is radical 1 minus 1, which is 0. 0 over 0, which is an indeterminate form. So since the top is not a polynomial, we can't think about factorization. In other words, we can't really use the dividing out technique at this moment. But what we can do, since we have a radical term at the top, we can multiply the top and the bottom by the conjugate of the numerator, because the radical term pops in the numerator. And here we go. So we are given the original fraction here. So what is the conjugate of this term? That's exactly what we need in this calculation. Well, the conjugate of that is the plus version of this. So essentially, it's this term. We multiply and divide by. So let's see what happens. So radical x plus 1 minus 1 times radical x plus 1 plus 1. So we're going to do like term by term multiplication. Okay, so let's do it. So radical x plus 1 times radical x plus 1 is x plus 1. So radical x plus 1 times 1 is radical x plus 1. You have minus 1 and radical x plus 1, so that's minus radical x plus 1. And finally, you have minus 1 times 1, that's minus 1. And the bottom, you don't need to expand it out all the way, just keep it as is, okay? So if you need, put everything in parentheses. Okay, let's see what kind of like simplification we have. So first off, these two terms are canceled out, and as well as 1 and negative 1. So we have x over x times radical x plus 1 plus 1. And luckily, you have x and x at the top and the bottom. So these guys are going to cancel. So you have 1 and 1, right? So that this whole thing is going to simplify to 1 over radical x plus 1 plus 1. So this is the g function that we are after, right? And here we go. We have the limit of f and limit of g. And limit of g is something that we can easily find out by using the direct substitution. So you have 1 over 0 plus 1 plus 1. That is, in fact, 1 over 2. You can also graph the function and check the limit graphically, as well as looking at the table of sample values to estimate the limit. Remember that the limit is 1/2. Okay, that's exactly what the values approach here. But the technique that we learned here the rationalizing technique that is sort of like detouring all the graphical and numerical estimations of limits of functions. All right, I think with one example we covered the rationalizing technique, so there are a bunch of different examples in your recitation videos and homework assignments. Please practice them. And I'm going to finish this video right here, but you continue to my next video to see what I'm going to say for the squeeze theorem, which is the last learning objective of this section. All right, bye.